So here we can see that each node represents a column in our data set, and these columns have three different set of colors. So the columns with the blue colors are the parent node or the source node, which are independent of any other nodes, and the ones in gray color are the kind of intermediate nodes which has parents as well as children, and these purple nodes are the leaf nodes or the sink nodes. There are no nodes that are dependent on these sink nodes. So here we selected specific nodes out of the all available columns based on our domain knowledge, and then we used PC algorithm to come up with the edges, this graph like structure, and then we used SHAP values to determine the weight of the edges. So here you can see the edge between water intake and BMI is slightly thinner than the edge between fat percentage and BMI. So we can understand how important or how important is one parent compared to other parents for a children node. Let's take an example. So let's say now we want to improve our calorie balance. So you can see that as we like select a particular node, the incoming edges are highlighted. So here now this calorie balance is dependent on two nodes, which is calories burned and weight. And also we can see that the edge for the weight to calorie balance is more thicker than the edge from calories burned to calorie balance, which means that weight influences our calorie balance more than the calories burned. So we can just hover over the edges to see the SHAP weight and influence trend. Influence strength is nothing but SHAP weight multiplied by 100. So here this edge weight is SHAP weight is 0.52, whereas for this edge the SHAP weight is 0.78. So we can say that this weight influences the calorie balance more. So now this calorie balance depends on this calories burned. So now if we select this calories burned, it is dependent on frequency and the workout duration. So we can say that if we increase the exercise duration, we can directly affect the calorie balance. Now let's travel along this edge. So now here we are in the weight node, and now this weight itself is dependent on two intermediate nodes, which is the BMI and lean mass. Here you can see that the edge between BMI and weight is thinner than the edge between lean mass and weight. So lean mass affects the weight more than BMI. So indirectly lean mass affects the calorie balance more than BMI. So now if we select the lean mass, it itself is dependent on BMI, fat percentage and water intake. And BMI is dependent on fat percentage and water intake. So somehow if we are going to play with water intake, fat percentage and then the duration, we can control the calorie balance. And here we can see that since this fat percentage heavily influences BMI and BMI heavily influences lean mass heavily influences weight heavily influences calorie balance. So this fat percentage affects the calorie balance the most in the parent source nodes. So this is just an example. Like that we can just iterate over each of this children node, which directly affects which directly quantifies the quality of our lifestyle, and then we can play with the source nodes to get to the optimal lifestyle. So this is the problem that we are trying to solve with this visualization. Thank you.